Hello, good day. Thanks for joining me. This is the Adobe Fikemba theory, and I told you in this channel you'll be taught physics, chemistry, and biology. So today we are going to be learning physics. Physics, and in physics we started by discussing measurement, and we talked about the measurement of length. I told you in that video. Go and watch my physics part one, part two, part three, part four. I guess you will see what I just talked about on that measurement. But we're still talking about measurement, and here we're going to be looking at measurement of volume. The previous one we looked at measurement of length. Now we want to look at measurement of volume. Measurement of volume. So what is volume? Volume is just a three-dimensional measure of space, okay, that deals with the length, the width, and the height. Three-dimensional measure of space that deals with the length, the width, and the height. Is that clear? Now, we want to look at measurement in relation to the three states of matter. So we're going to start with solid. If you're going to measure a liquid, liquid assume the shape of their container. When you pour a liquid in a container, maybe if you put it in a 2-liter container, 4-liter, depending, it's very easy to know what the measurement of that liquid is. Also, to know that of a gas is also very easy. All you need to do, the gas has some characteristics such as they can diffuse, they can expand, and they can compress. So in the case of compressibility of gas, you can compress gas into a cylinder. And then with that, if the gas cylinder is 5 kg cylinder, 4 kg cylinder, 12.5 as the case may be, you already know what the measurement looks like. But in the case of solid, there is a peculiarity when it comes to solid. Now that has to do with solid. In determining the volume of solid, you will have to know what type of solid you are dealing with. Number one, for the case of solid, we have what we call a regular solid. Okay, regular solid. And we also have number two, irregular solid. Now I want you to understand something. If we're going to get the volume of a regular solid, we can obtain the volume from mathematical formulas. Okay, from mathematical what formula? Take for example the volume of a spherical. Take for example the volume Take, for example, the volume of a spherical object. So let me just tabularize it, okay? Let me tabularize it. Let's say we are dealing with regular solid, okay? Regular solid. So let's say the volume of so this is formula, and this is the object, okay? So let's say, for example, volume of a spherical object. Okay, volume of a spherical object 4/3 pi r cube. Okay, let's look at volume of an hemisphere. Hemisphere. Okay, so this one, these two. Volume of a hemisphere will be 2/3 pi r cube. Let's look at number three. Volume of a rectangle. Okay, volume of a rectangle when the object is a rectangle, but it's for regular solid to be length times breadth times height. Then number four, let's look at the volume of a cylinder. Okay, volume of a cylinder. You have pi r square h. Volume of a cylinder. Let's look at maybe number five, conical objects. Conical objects. Okay, it will be 1/3 pi r square h. Okay, volume of a conical object will be 1/3 pi r square h. Is that taken? So this is for regular solids. So now when we look at irregular solids here, for the case of irregular solids, we're going to be getting our, what's it called? Our volume from the displacement of the liquid, obtained a formula propounded by Archimedes. Okay, Archimedes, that principle states that when an object is placed in a liquid, okay, when an object is partly or wholly placed in a liquid, that object experiences an upthrust, okay, which is equal to the weight of the liquid displaced. So in that case, for you to get the volume of that irregular object, it will now be the difference between the volume of that object, between the volume before immersion and after immersion. So take, for example, for those of you writing, see this now, okay? So for regular solid, we'll get the volume of an irregular solid using what? Archimedes principle. So volume of an irregular solid will be by what? Archimedes principle. Archimedes principle. Okay? That has to do with the displacement of the fluid. So let's say, for example, this is a container containing water. Now, this was the level of the water. This is the level of the water before immersion. And this is the object in here. So you have something like this. So now you can see this is V1, while this is what? V2. So you will observe that this volume, to get the volume of solid will now be equals to the difference in this volume. This object have displaced this fluid. So to get the volume of this irregular solid, this one is irregular what? Solid. So to get the volume of this irregular solid will be, so volume of irregular solid. So to get the volume of this irregular solid, it will be the V2 minus V1. This V1 was the volume before immersion. So V1 is volume before what? Immersion. What is immersion? Before we put the irregular solid into the water, okay, the volume was, this was the initial point. But immediately we did that, there was a displacement of this fluid, okay? The fluid was displaced by this object such that it made the volume to come to this point of the water. So we now have V2. So the volume of irregular solid will be obtained using this Archimedes principle, where the fluid or the water is what? The liquid is displaced. So with this, we've known what it looks like to deal with the measurement of a solid, okay? Both regular solid and irregular solid. In our next video, we'll be looking at measurement of mass and also other quantities as related. Please, I'd like you to subscribe to my YouTube channel. I'd like you to also share.